mga ka-BSS, Buhay, sorry. So, today's John Lee Stocks episode will be about light. What is light?
Light?
Wait, we do have a lot of examples of light here. Light is all around us, from the sun, the moon. It actually reflects light.
Could you just introduce first ourselves?
Oh yeah, I forgot we have a new guest.
Mommy!
Woo! The
And
mother and daddy.
that's me.
And the most handsome
We
one
are
in
the...
and the most handsome one in the channel, me.
Yes, good evening everybody.
Let's
We
go
are
back
here.
to light.
We are here in the
Ano ba ang light?
house.
Matter ba ang light?
Well, technically, light isn't really matter. It's not really a solid, liquid, nor gas. It's actually kind of not. It has zero.
Anyway,
Yeah, correct.
what are the
Light is
materials
not
we're going to use for our experiment?
First, before we go to the experiment, I'm gonna explain to you a basic summary of what is light. Light is basically just some wavelengths. The wavelengths you see, like radio, is basically the same. Radio waves is basically the same as the gamma rays. It's basically the same, but gamma rays light wavelengths is a bit shorter or smaller, because the smaller a wavelength is, the more energy it has. So radio waves are very long. Some can even reach to big lengths, like 1 kilometer or something.
Yeah.
The world record for the longest radio waves was actually 10 kilometers.
So, ano ka bilis mag-travel ang light?
Lights.
Well, the speed, all wavelengths travel at the speed of C, aka 300 million kilometers per second.
So,
That's fast enough to reach from Earth to Moon in just 1 second.
can we go on to our experiment? What are those materials?
Yeah, if you're wondering, this water is not for drinking. It's for putting in pencils. Oh
What
wait.
happened to the pencil?
Okay. What do you observe?
Parang
For
tumaba
but
yata
here,
ang
see, I think the
pencil,
camera doesn't really. But you have something. The pencil
Honey, look at the pencil.
is
It looks...
the light is being enhanced, or it's getting magnified. You have a magnifying glass.
looks
That's
like
basically light.
broken.
It's not really broken. See,
Yeah.
that's just light
And you see
bending.
it in the water.
So-
Because light
Becomes-
Can we show it to the people around
Yes.
over there?
It
There
becomes
is a-
bigger.
light
See?
actually moves slower. Light actually moves slower in the water. But this is an example of how light can be easily manipulated. For this, a pencil can look normal, but when dipped in water, half of the body seems like it has been broken or fractured. But in truth, the pencil just got magnified.
So,
And it only
what do we call it?
So it's basically refraction. You only
It's
got.
refraction.
What is refraction?
I'm gonna see what the dictionary says.
Oh, you made.
Based on that,
Based on your observation.
But based on my observation, refraction is like light waves light waves just being bent. When light enters the water, it moves a little slower, and it also has to move through a lot of water particles. So it has to bounce. So that's what I think is
so in
refraction.
short, bending of light.
Yeah, let's see how
Okay,
close
look
my.
at the dictionary.
Let's see
Can
how
we go on?
The meaning
Because
of
it's too,
refraction.
contagious if you're just
Yeah,
reading
okay.
in the dictionary.
Okay, next example is light.
No. What's this?
Oh, that's a pen.
Pen with
Seal. But it's not just an ordinary pen. It's actually a photonic.
Oo.
Basically, it's like.
what's this?
It's just basically funneling photons at very high speeds while giving them energy at the same time.
So, what we
Basically
can
a
expect
laser.
about this one? Laser.
Yes.
Okay.
A very
Okay,
powerful.
can you show it?
Yes. So, this is what happens when a laser hits an object.
What do we call that?
That's called photons hitting a surface, and the photons being reflected back to your eyes, and your retinas being absorbed, and the light being absorbed by your eyes.
Okay.
Most importantly,
And then, what do we learn about this one?
it's basically our just demonstration, because we can't use normal lights, but you can't really see it that well.
So,
Now,
the next
here's-
one.
Now,
What is one?
This
What's
is a
this one?
prism. This will be used for later.
Can we just
Yes,
please
play
show
with
it to
it.
the people?
Play with it.
This
for a
one
second.
is
A prism.
prism. Okay.
Very easy to spell. So normally, without the prism intervening, the light would hit this wall, our imaginary wall. Would hit this. But if you insert a prism, you can see that the wall is no longer being hit and the light being reflected back down to the ground. It can also be used to do this.
In different ways.
Yes, but the camera can't really see well. But as you can see, if here you can see that the light is being scattered.
Can we focus
It's
it
like
to
super radiant scattering.
the camera? To show to the people?
Yes, they can't really see it that well because you have to see. But if you look at mommy,
See? What do we call that?
that's super radiant scattering. Basically, it's basically bouncing around an object and then
Okay.
keep bouncing around.
What do you call
an
this?
object. That's called a prism.
This one.
And this is a laser pointer.
And then,
Okay.
Okay, so
what next?
usually I would say light is it is confused. How do you light even make being this? How do you make light?
I don't know. You're the one who's making an experiment, so
Wait,
we are just one asking question, throwing a question, and you're going to answer it. What next?
and there's just another example. When you have an atom, you have one imaginary atom. Like, okay, so this is the nucleus and this is the electron. The electron can go when an electron go up or farther from the neutron. It basically means that it has a lot of energy and it's very excited. So all that energy will be what's that called? What's that word?
I don't know what is the word.
Being released from the atom, from the electron, and thus the electron is going down. That's how the light from the sun is created. It's basically heat. And also light, because light is both a particle and a wave. It can be a wave. It can be a wave because it's heat, and a particle since it can interact with objects.
Okay. What the next? Okay. Oh, can we sum up our experiment today?
So basically, this experiment is practically the easiest experiment we've ever done, and probably needs more research than what I deemed. But still, light is cool. I wish we still had the disco ball, because that is a much better example of super radiant scattering.
Okay.
Okay.
What are now?
You want the summary?
Okay.
Oh, you want the summary? The summary is basically
Okay.
light is very fast. It is basically at the speed limit of the universe, practically 300 million kilometers per second, and that's practically the speed limit. And light is both a particle and a wave. It's a wave because it can transform.
Alin ang mas mabilis mag-travel? Ang sounds or ang light?
Light wins by a margin since sound is we are already breaking the speeds of sound. That's called Mach 3. Most fighter jets can easily break the speed of sound, but light is extremely faster. Like the speed of sound is practically pretty slow for light.
What are those example? Can you give an example about the sound?
That's a sound.
So,
But for now, since we're at an enclosed space and it's very small, you might hear it instantly. That's basically the sun to us. But when you go to farther away, like 1,000 kilometers and your sound is very loud, it may take for you a while before you hear it. But that's also how some light works. When your distance is over 1 year for light, or aka a light year, the point where light is where the distance where light takes a year to reach you, you're basically seeing the past of this object. Imagine this: if this prism was still here 10 billion years ago and emitted the last ray of light, we would be us being created or being born. And we are only seeing it just being formed because that's how delayed we are. And in the grand scheme of things, light is practically very slow, as the universe is billions of light years wide, and it would take billions of years for light to even reach us from the distant galaxy. And also, when the universe eventually becomes so big that it outspeeds the speed of light, it would
Ouch! Don't broken na lang.
it would practically mean that we'll be sailing through this empty universe, while the newer generations can only see their galaxy. They can never see background radiation. They can never know what we know. The only thing they would think of that the universe is eternal and static, but they will never know the future ahead of it.
Okay. For the sum up of the experiment of my child, of course, for now, this is the materials we presented. The pen, the laser pen, this one, the prism, and this one, a glass of water, and a pencil. All of these materials you can find it in your house. But this one, we want this.
I wouldn't expect you to have a prism and a laser pointer.
Hello?
Wait, cut the camera. Bing!
Like, share, comment, subscribe.